All right, so let's look at number 1 and number 2. That's all we're going to do together, and then you can do however much of the rest you would like to. If you look down the first page there, 1 through 5, they're all set up basically the same way. Like, they give you an equation, and they ask you to find all the places, basically where does calculus slope equal algebra slope. And they all have an answer choice. They all have an answer choice that suggests that MVT doesn't work. So I've got to check them all, and if it doesn't work, then I can circle D and move on. So like you kind of hope that the answer is D because that's an easier problem, and there's not really any algebra. All right, we're going to do 1 and 2. If f of x equals x cubed plus 2x, find everything, or find all values between -1 and 1 which satisfy the MVT. Okay, x cubed plus 2x. Do you know roughly what that looks like? Remember what x cubed looks like? Or do you know enough to say whether it's continuous and differentiable? It is, because polynomials are continuous and differentiable everywhere. So polynomials are easy to deal with. So I know it's not D, like MVT applies. So I can throw out D. D is not going to be the answer. Like there's going to be at least one answer. So if it applies, that means the derivative equals the algebra slope. So 3x squared plus 2 equals, well, I've got to do the algebra slope. F of 1, f of -1, f of 1's easy. F of -1, a little harder, but so y2 minus y1 over x2 minus x1. 6 over 2 is 3. Okay, so my algebra slope was pressed for time, or pressed for space. I didn't write IROC equals AROC. But the AROC is 3. The IROC is that equation. We set them equal to each other. Solve for x, and that'll be our answer. So 3x squared equals 1. X squared equals 1/3. I square root both sides. B is definitely out. It looks like A, but I intentionally did something wrong. What did I do wrong there? When you put the square roots on, you've got to remember to put the plus or minus on there. And then for these, you have to check to see what's on the interval. So is it on -1 to 1? Well, it's the only one left, so it's got to be right. But the square root of 1/3 is between -1 and 1, so we're good there. There will be times where you will get two answers. One of them's on the interval and one's not on the interval. Don't give both answers. Only give them the ones that are on the interval. Number 2. G of x equals absolute value. Is absolute value continuous and differentiable everywhere? Why not? There's a cusp or a corner somewhere. So I need to figure out where that corner is. So continuous, yes, but not differentiable at the cusp. So I need to figure out where the cusp is. If the cusp is in the interval, then this problem is over and it doesn't work. If the cusp is outside the interval, then it's fine. I can just work the problem. So how do I figure out where that cusp is? Do you know how to figure out where the cusp of an absolute value is? It's where the inside equals 0. because that would be where it makes the change from being positive to negative. It's at its lowest point there. So there's a cusp at -1/2. I don't want to say is that good news or bad news. Does that mean, is -1/2 in the interval? Yes. So what am I saying about MVT? So MVT does not apply. So that means the answer is D, and I don't have to do anything. My guess is if you did the AROC equals IROC, you'd probably get one of those answers, but we shouldn't go that far. This doesn't work. I'm looking ahead. What is remember what the graph of tangent looks like? Let's see, it goes through 0, does that, it repeats every pi. So there's an asymptote at pi/2. I think I just answered number 5 for you. What's the answer to number 5? Why does MVT not work? There's an asymptote in my interval, right? If they had given me an interval from like -pi/4 to pi/4, then it would work. But they wanted to go from 0 to 2 pi. So yeah, you're going to have another asymptote in there too. So that one's out. We like those. All right. Hopefully tomorrow we'll have a more complete worksheet to deal with.